Hello, here's standard 7.3. All right, proportions. So standard 7.3, I can analyze proportional relationships. Let's define. Proportion is an equation, right? An equation, so the equal sign, with two ratios in fraction form, right? Here's an example one. Here we have 2 to 3 equals 10 to 15. We could also call this 2 over 3 equals 10 over 15. All right, 2/3 equals 10/15. Doesn't matter. They're fractions. They're standing in for ratios. All right. Cross product. Here's how we interact with this. So cross product. When you multiply the numerator of one ratio by the denominator of the other, right, which would be this shape, right, or this shape, right. We call this. You've probably called this in the past. Whoops. The butterfly method, right? Because if you draw that nicely, it looks like butterfly wings. So here's an example. We're going to do 6/9 equals 8/12. All right, so let's do butterfly method. Let's start with the first one. We're going to start with this numerator, and I'm going to go this way and write, actually scratch that. I want to go around this way, and I'm going to write it on the same side as the top number. So 6 times 12 makes 72. Let's actually write it out here, not 7.2. 6 times 12 equals 72. The other one is going to be 8 times 9. 8 times 9. 72. Well, look at that. And they equal each other. When you do this and the two sides equal each other, that makes this a proportion. Proportion allows us to find out information. We can decide something is a proportion, or we can use the proportional relationship to identify one of the four numbers. Okay, good thing to know, right? You'll use this if you ever plan on painting anything that isn't just straight opening a can, right? Or cooking. Lots of cooking uses this. Chemistry, if you're going to take chemistry, we'll use proportions sometimes. So it's a pretty standard skill. It's known. This is a good way to start dipping into it. So let's see. Here's when proportions meet algebra. Solve each proportion using cross products where necessary, round to the nearest tenth. So let's take a look at this. So we're going to write them on this side. Let's write it out. So we have 6 times x. So we're going to write 6x equal sign. And then we're going to do 4 times 9. So 4 times 9 is going to be, let's see, 4 times 9, 36. All right. And then we can go back and use algebra, single step algebra, and say, okay, if I need to know what x is, I'm going to divide by 6 and divide by 6. That's going to give me x equals 6. So 6/9 is the same thing as 4/6, right? Let's do another one. This time let's do green. So we're going to have 3 times 9. So 3 times 9 gets us 27. And then our other one is going to be x times 2. X times 2, so it's going to give us 2x. And then just like before, we can divide both sides by 2 to get our answer. X is going to be equal to, let's see, half of 27 would be 13.5. Yeah. So 3 over 13.5 is the same thing as 2 over 9. It's weird, I know, but that's what it is. Let's do another one. Pick some different colors. Let's do orange and black. So we're going to have 8 times 11. Notice I'm going to write on the same side as the top number. 8 times 11 makes 88. Equal sign. And the other one is going to be x times 21. X times 21 is going to give us 21x. And then I'm going to solve it by dividing both sides by 21. That's going to give me, I'll do the math on the calculator on this one, 88 divided by 21. This gives me 4.19047619. Wow. But you know what? We want to round it to the nearest tenth. So 9 tells that to go up, so we're going to call this 4.2, or x equals 4.2. All right, that's how we round it, right? 9 says that this one goes up 1, so x equals 4.2. All right, so it's not an exact proportion, but that's going to be how we round it to get the fit. Okay, you can use that to get a pretty close answer all the time. Right? Let's do the next one. Real world example, solve each proportion, where necessary, round to the nearest tenth. If you could buy 3 ounces of meat for $1.65, so I would probably think of this as not ounces per dollar, but dollars per ounce. I'm going to call it 1.65 over 3. How much would 5 ounces cost? So question mark. So question mark. Or let's say, not question mark, we don't want a question mark. I want X. X, right? No. I read that wrong. $1.65 over 3 ounces. So we have the ounces are both there, right? So we know it's 5. That means I want X on top because we don't know the cost, right? So now we're going to multiply diagonally. So we have $1.65 times 5. $0.65 times 5 equals $8.25. And then we have 3x on the other side, 3x. And then I'm going to divide both by 3. That's going to give me 275. 275. X equals $2.75. That's how much 5 ounce would cost if 3 ounces cost $1.65. Right? So cross multiply and then divide by whatever's with your X. Let's do one more. If you can run 3 miles in 28 minutes, how far can you run in 1 hour? 3 miles in 28 minutes. Okay, I'm not sure which way to do on this one, so let's just write it out. We'll do 3 miles, 28 minutes equals how far can you run in 1 hour? So how far? Let's call that X. So X in 1 hour. So I don't want to write 1 though, right? That's actually 60 minutes, right? So I'm going to write over 60, and then I'm going to multiply 3 times 60. 3 times 60 makes 180. X times 28 equals 28x. And then to solve, I'm going to divide both sides by 28 to get x equals 180 divided by 28 equals, ooh, it's a long one, so it's 6.42857143. I want to round to the nearest tenth, so that tells me this one tells me to keep that the same. So I would run x equals 6.4 miles. All right. Got to keep kind of rolling around. All right, homework. Here's our homework. Look what it is. A whole bunch of proportions to solve. Show us the work. Show work. Show work. Work. Show work. Work it. Show work. Show us it. Show us the work. My goodness, I can't say it enough. People aren't going to do it. Find the x value. So you need like x equals or y equals, right? But show us what you're doing. On the back, you have 1, 2, 3, 4, 5 word problems. Do your best to get those set up successfully. All right? And then our answers are posted. Thank you.